So this says use the function f of xy is y equals 3x minus 1. So they've given you the function there, y equals 3x minus 1. They have given you the input, which is the domain, x equals -1, 1, and 3. And then they've asked you some questions about that function. The first question they ask is, find f of -1. That literally means plug -1 into that function 3x minus 1. And so when you do that, you will get that it equals -4. -4. The next thing they ask for is to state the domain and range. Well, the domain they handed to you in the question. The domain is the input, or the x values, -1, 1, and 3. The range would be the y values after you plug those x values in. Okay, and so they handed you part of it. You've already solved for part of it. The first answer to that, -4, you solved over here. The other two, you just had to plug in a 1. 3 times 1 minus 1 gave us 2. Plug in a 3. 3 times 3 minus 1 gave us an 8. So the domain was handed to you, the range you found by plugging it in. Okay? Make sense? All right, the next thing they wanted was a mapping diagram. The mapping diagram is the two circles, or I usually use rectangles actually when I do it. These are kind of rounded ones. Domain least to greatest. So you're going to list the domain just like it was here. You're going to list it down. The range, just like it was here, you're going to list it down. And then you just draw an arrow from the input to the output. When you plugged in a -1, you got -4. When you plugged in a +1, you got +2. When you plugged in a 3, you got 8. Now this actually created ordered pairs. The ordered pairs -1, -4, 1, 2, and 3, 8. So when it says graph the function, they literally want you to put it on a coordinate plane. So they want the -1, -4, the 1, 2, and the 3, 8 just plotted on a plane, on a coordinate plane there. That's what graphing it means. This was not a line. Like they didn't say, technically this represents a linear equation, but they gave you 3 specific domains, right? 3 specific numbers. They didn't say it was all real numbers. So you didn't even have to connect these dots. You literally just had to put the 3 dots on the coordinate plane. We are going to start with the most common form of a linear equation, which is the slope-intercept form. It is in the form y equals mx plus b. M being the coefficient of your x. And m represents the slope of this line. Slope meaning we already talked about it in the last section, but how far it goes up compared to how far it goes over. That is the slope. The b is the y-intercept of this line. Y-intercept is where it crosses the y-axis, okay? So when it is in this form, and I ask for slope, there is no solving involved. You literally tell me the number in front of the x. That is your slope when it is in this form, all right? In section 2, we looked at it in standard form, ax plus by equals c. When it's in that form, you can't just take the number in front of the x. You have to move it over -a over b, right, to find the slope. But when it's in this form, it's actually handed right to you. All right, and so the first example wants us to write an equation using the slope-intercept form to do it. All right, and so they are telling us, they want us to write a linear function modeling the line that passes through the point 2, 1 with a slope of 2/3, okay? Now, the first way you can do this is to simply take this equation and plug in what you know, all right? So they have given us a point. Well, a point consists of an x and a y, right? So they have given us an x and a y. They've also given us the slope. Which of those letters represents slope? M. So they also gave us the m, all right? So really the only one we don't know in this equation is the b. In order to write the equation, though, we need the slope and the y-intercept. And so what we're going to do is we're going to plug in everything we know and solve for that b, and then we're going to rewrite it in slope-intercept form. So we are going to say y. Well, our y is what number? 1. So 1 equals m. What was our m? 2/3. X. What was our x? 2 plus b. All right? And so now we can solve for our y-intercept. We're just going to use solving an equation, right? So we have 2/3 times 2. And remember, this is over 1. We just multiply our numerators and our denominators. We get 4/3 plus b. then we are going to subtract the 4/3 over. Minus 4/3 minus 4/3. 1 written with a denominator of 3 is just 3 over 3. Anytime you have a 1, it's just going to be that number over that number, right? So we can rewrite that as 3 over 3, right? 3 over 3 is just 1, right? 3 over 3 minus 4 over 3 gives us what? Negative 1 over 3. That is our B, okay? So now we know our B and our M, and we can now write our equation. For our equation, that's all we fill in, the slope and the y-intercept. So our equation is going to look like this. Y equals M, well, that's 2/3, X plus, but this is a negative. So instead of writing plus a negative 1/3, we're just going to say minus 1/3. And that is our equation in slope-intercept form using slope-intercept, okay? Using slope-intercept. All right, questions on finding using your y equals mx plus b. It says a third form. So we have talked about standard form and we have talked about slope-intercept form, which you are familiar with those. It says a third form is point slope. Point slope. Now this is the one that we have used in the past over and over and over when we do parallel lines and perpendicular lines and things like that. All right. It's taken from the slope formula. So if you know the slope formula is y2 minus y1 over x2 minus x1. What they basically do is they multiply both sides by this entire group. They multiply it over, and you're left with just the y minus y1 equals mx minus x1. That is your point slope equation. And they actually give you the definition there. The equation of the line passing through the point x1, y1 with the slope m can be found using the point slope form. The point slope form is y minus y1 equals m times x minus x1. It's just basically your slope equation split up, right? They've just moved that denominator over. All right, and so you can do that same process that we just did, but using that equation, all right? And so when you do this, you don't have to plug stuff back in. Once you solve it for y, you're done. So the first way you have to solve for your y-intercept, and then you have to go back and plug in your m and your b. This way, you're going to actually get your equation when you're done. So we are going to use the y minus y1 equals mx minus x1. Now in this case, we're going to say they gave us x1, they gave us y1, and they gave us m. All right? And we're going to plug it in. We're going to say y minus my y1, which is 1, equals m x minus my x1, which is 2. All right? What's my first step here on that right side? What do I need to do?
Multiply.
Yeah, I need to distribute through. 2/3 times x, 2/3 times negative 2. All right? And then what's my final step to get y by itself?
Add 1.
Yeah, so I'm going to add 1. All right, once again, I need a common denominator, so a 1 is going to be 3 over 3, right? It's easy when it's a 1. Negative 4 plus 3 is going to be negative 1. This is the same answer we got before, right? Both ways solve it. Whichever way is easiest for you is really fine. You can use your slope-intercept, you can use your point slope, unless it tells you specifically which one to use. So I think in the instructions it actually tells you which one to use. But given like a test and I say find the line that goes through this point using this slope, you can literally do either method and you're going to come to the same answer, as you can see based on this example. So in this case, they have given us a problem. It says write the slope-intercept form. So which one does it want my answer in? Slope-intercept. So when they ask you this and you're taking a test, you may want to make a note that you are looking for y equals mx plus b as your final answer. How you solve it's fine, but your final answer needs to look like that. They have given us 2 points, all right? Well, that's great, except that with 2 points, I need the slope, all right? And so the first thing I'm going to do here is find the slope. So I do have to use my slope formula, which is just subtract your y's, subtract your x's, all right? And so the first thing I'm going to do is I'm going to find my slope. I'm going to say my y's, 3 minus 6, over my x's, negative 4 minus 2. All right. So I have 3 minus 6 is negative 3. Negative 4 minus 2 is negative 6. That reduces, right, to positive 1/2. All right. Now I can use either method. All right. I only have to use one of my numbers. So I can choose to either do the 4 and the 3, negative 4 and the 3, or the 2 and the 6. Only one of my points do I have to use, but I have to use one or the other method. So you can either use your y equals mx plus b. So y equals mx plus b to solve for b. Or you can use your point slope. Y minus your y1 equals mx minus your x1. All right, either one. Whatever you do, you need to solve for it. So I have 6 equals 1/2 times 2 is 1. Subtract your 1 over. B equals 5. I am not done. My answer needs to be in what form? Slope-intercept. So I have to go back and write it out. Y equals my m. This was my m. X plus my b. This was my b. If I choose to solve it the other way, that's fine. You have to distribute. Y minus 6 equals 1/2 x minus 1. Add your 6 over. Y equals 1/2 x plus 5. You'll see this was in my form that I needed it in once I solved, right? I didn't have to go back and plug anything in. But either way, I got the same answer. I had to solve for slope first, and then I needed to use one of those methods with one of my points and my slope to solve for my slope-intercept form. All right, so again, we have talked about this in Algebra 1 and in geometry, but just remember that parallel lines have the same slope, exactly same slope, okay? If the slope of this line is 2 and the slope of that line is 2, they are parallel lines as long as they aren't exact the same line, right? So as long as they're not the same line, they have the same slope. And then perpendicular lines, their slopes are negative reciprocals of each other. So for a perpendicular line, you have to flip the slope and negate it. By negate, I mean change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive, okay? So you'll notice these lines here. This was a positive 3/2 slope, a positive 3/2 slope. They are parallel lines. We have a negative 1/3 slope with a positive 3 slope. Those are perpendicular lines, okay? And so that's how those will always work. So the next question tells us, write the standard form of the equation of the line passing through the point -2, 3 and parallel to x plus 2y equals 8, okay? So this is making you think of several different things that you need to know. First, the answer needs to be in standard form. Standard form is ax plus by equals c. And typically you don't have fractions. and your A is positive, okay? And I'm telling you this because on a standardized test, they almost always do the first number is as a positive number, okay? So even if you have to negate everything. Standard form of equation, ax plus by equals c. They want it to go through the point -2, 3, and they want it to be parallel to the line x plus 2y equals 8. Now this line that they gave us is not in slope-intercept form. So you cannot assume that the number in front of the x is your slope, all right? Remember, for a standard form, your slope is going to be -a over b, okay? In standard form, you would subtract your x over and then divide by your b. That's how you would get your slope, okay? So when they give it to you this way, you need to figure out your slope before you just start plugging stuff in. So for this particular line right here, my slope is going to be -a. What is a here? What's in front of my x? A +1. So I want -a, -1, over b. What's my b? It's my coefficient of my y, right? So it's going to be 2. So my slope of this line is -1/2. -1/2. They told me another key word. The word here is parallel. All right? So the only thing I care about from that line is the slope. All right? And I want it to be the same slope because it's parallel. So when you want it in standard form, you're going to have to, if you have a point in the slope, you're going to have to use your point slope here. All right? Because finding the y-intercept doesn't really help you because you can't pull your y-intercept from standard form. So we have our x1, we have our y1, and now we have found our m. And we're just going to plug it in. So we have y minus our y1. What is our y1 from this point? 3. Our m, we said, was -1/2. And then x minus a -2 is +2, right? Minus a -2. Now they want this in standard form. Standard form means I move all of my x's and y's over to the left-hand side and I move all my numbers over to the right-hand side, okay? So I am going to distribute to get it out of the parentheses there. So I have y minus 3 over here, -1/2 x, -1/2 times +2 is -1. I need that x over to the other side, and I need that -3 over to the other side. So I'm going to move this 1/2 x over. It does not combine with anything, all right? So I have 1/2 x plus y, and I also need to move that 3 over here. So 1/2 x plus y equals 2. One other problem here is I need whole numbers or integers, okay? Integers. I have a number here that is not an integer. Which one of those numbers is not an integer? The 1/2, okay? The way you get rid of fractions is you multiply everything by the denominator, okay? If I had had multiple fractions, I would have done a common denominator. But I only have one denominator. What is it? What's my denominator? 2. I need to multiply everything by that 2. So I'm going to multiply this by 2. I'm going to multiply this by 2, and I'm going to multiply this by 2. Everything by the denominator, because standard form has integers, not fractions, okay? So 2 times 1/2, that just gets rid of my denominator. That gives me just a 1x. 2 times y, well, that just gives me 2y, and 2 times 2 gives me 4. This is the standard form of that line, x plus 2y equals 4. X plus 2y equals 4. So the same process, you need to figure out what your slope is. It's parallel, so whatever that slope was, that's what you're going to use. Use your point slope, but instead of now solving for y, which would be slope intercept, get your x's and y's to one side, get your numbers to the other side, okay? And then make sure you don't have any fractions. Make sure there's no fractions involved at that point. Get rid of your fractions. Now, I will also say on a standardized test, they will ask for the standard form, right? And you will have found 1/2 x plus y equals 2, and you will not see your answer. It's always good to recognize your answer in a multiple choice test, okay? Because you would hate to actually get this and choose the wrong one because you just didn't see your answer in there, All right. So make sure you recognize that those are the same lines. They just multiplied 1 by 2 to get rid of your fractions. All right. It says write the slope-intercept form. So what do they want your answer in? What form? What's it sound like?
Y equals mx plus
Yeah, so they said slope-intercept. So I'm going to make a note that my answer needs to be like this. Okay? Of the equation of the line passing through the point, they've given me a point, and perpendicular to this graph. Well, in order to know that it's perpendicular, what do I need to know about this graph?
the slope.
I need to know the slope. All right, so when you're given a graph, to find the slope, you can either pick 2 points or you can literally walk from 2 points, okay? So when you're looking at this, is your slope going to be positive or negative? Yes, positive. How do you know that? Well, from left to right, what direction is it going? It's going up, right? From left to right, it's going up. So yes, it's a positive slope, all right? Had it been going down from left to right, you would have been a negative slope, all right? So first of all, you know that it's a positive slope because it's going up. The next thing you're going to look at is just pick 2 points. When I say 2 points, it has to cross specific point. Don't pick like in the middle of 2 points. That's not very smart because you're going to have to estimate it. So pick where it crosses over an X and a Y, all right? Where you're not having to guess. And then you don't even have to know what the points are, honestly, if it's a graph. You don't have to use your slope formula if you don't want to. If you want to, you're welcome to. That's the point 2, 1 and the point, 3, 4, okay? But if you just pick 2 points on the graph, you can literally walk it. Your numerator is going to be how far up or down you go. In this case, a positive slope, up. So I'm going to say I go up 1, 2, 3. That's my numerator of my slope. My denominator is how far over I go. Well, I go over 1. My slope here is positive 3. All right, so when they give you a graph, you don't even have to remember the formula really, right? You can just walk it. Walk it from one point to the next. Or if you want to pick those points and do your subtraction, go for it, all right? Once I know the slope, I have to look at this keyword right here. Perpendicular. I am not going to use 3. What am I going to use here for my slope of the line I'm looking for? I need to flip it. How do I flip a 3? What's the reciprocal of 3? 1/3. It was a positive slope. I need to make this a negative slope. All right? Now, once I have this, and I know they want slope-intercept, I can use either of my methods. I can use the slope-intercept method or my point-slope method. It does not matter because my final answer is going to be in slope-intercept. I really just need to know my y-intercept, okay? So you can use your y equals mx plus b if you want to. I would say my y value is 1 because they gave it 2, equals my m is negative 1/3, my x is 3 plus b, all right? 1 equals negative 1/3 times 3 is negative 1. Add the 1 over, b equals 2. So I know my m, I know my b. This is the format they want my answer. So my answer is going to be y equals m, negative 1/3, x plus my b, which was 2. So they can hand you a linear equation by a word problem. There's a couple ways they can do it. Here, they actually give us 2 points. Sometimes they'll say, it starts here and the rate of change was this. Starts here, y-intercept, rate of change, slope, okay? But sometimes they'll give you 2 sets of things. It says a race car driver was performing an engine stress test and he drives at a constant speed around a test track. After 20 minutes, he drove 60 miles. After 30 minutes, he drove 90 miles, okay? That is my XY. So they gave me X 20, Y 60, X 30, Y 90. They want me to give a function that models this. My function is going to be y equals mx plus b, okay? To find my m, I'm going to do exactly what I would do before. I'm going to subtract my y's, subtract my x's. All right, I get 30 over 10, which is just 3, and this is my miles per minute. All right, 3, that's my slope. They want a function. Well, y equals mx plus b is fine. I can use this one. Y equals mx plus b. My b here is going to be 0. 60 equals 60 plus b. By the way, your y-intercept in a word problem is usually your starting amount. How fast would he have started in a car? 0, right? So it makes sense that my y-intercept here would be 0. This is a logical starting point when you're in a car. Most people start at 0 miles per minute in a car, right? Now that I know my slope and my y-intercept, I can plug it in. Y equals mx plus b. So y equals 3x. All right, they used it with time, by the way. So they went, they did a function format. So they did this, or they said dt equals 3t. But this is fine. This represents the same thing. Y equals mx plus b. And so they can hand you a word problem and they can give you slope, y-intercept, but it's going to be hidden in the words. Or they can give you xy. And all they've done is given you 2 sets of points. They've actually asked the same question we've been looking at. Find the equation between these 2 points, but they hid the points in the word problem, okay? An xy and an xy. And so solving it is exactly the same. Solve for your slope, use your y equals mx plus b.
I must have missed a number when I did it before, but turns out I was using the wrong. I was trying to figure out for the trick that I do where you separate the cards. I was trying to figure out what the odds of doing that on accident are. It's not 52 factorial; it's 2 to the 52nd.
That's a big difference.
No, but at first I did 52 factorial, and I thought it was